Let's begin. Today's November 13th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 2, 12, 16, 19, and 20. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A takes a look at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should the value be equal to 3? Or should the value of triangle be greater than 3? Criteria card B takes a look at our first and last digits, the triangle and circle, and compares them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card C will take a look at our 3-digit solution, and it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card D we'll take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E, again, takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. There are 3 scenarios, the first one being that the solution has no repetitions, as in the example 1, 2, 5. And another scenario is that it could be a double number, meaning that there's a repeating digit, as in the example 1, 1, 2. And finally, it could be a triple number, where it's the same digit repeated 3 times, as in the example 2, 2, 2. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is I'd like to know a little bit about the ratio of even to odds. So let's go ahead and test criteria card C. Okay, so the Turing Machine does approve of my proposal, 314. Notice that I do have 2 odds to a single even. The Turing Machine confirms that that's a good ratio, and so what we'll type in our notes in section C is that there should be less even than odds. Now I should say that even though my proposal fulfills that requirement or that criteria, it doesn't mean that it has to be 2 odds to a single even. We just know that there should be a majority of odds. So it could be that you have 2 odds and an even, or it could be an all-odd solution. Okay, let's see, what else can we test? Well, let's go ahead and test criteria card D. Okay, so the Turing Machine does not approve of my choice. Well, for triangle and square, I've got 3 and 1. If I add those together, that's 4. And 4 is less than 6, but the Turing Machine does not agree with that. So either the sum of the first 2 digits should be equal to 6, or it should be greater than 6. So let's go ahead and type that up in our notes in section D. And that again is that triangle plus square is either going to be equal to 6 or be greater than 6. Okay, and at this point, it's still up in the air. You could have, a combination of 1 and 5 to give us 6, or 4 and 2 to give us 6. We may even have a pair of 3s. It's still quite up in the air. So let's see, what else can we test? Well, Let's go ahead and test criteria card E. Okay, so the Turing Machine does not agree with my proposal. Notice that 3, 1, 4 are all distinct, meaning there are no repetitions, but the Turing Machine does not agree with that. So either we're looking at a triple number or a double number. Now, at this point, I don't think it could be a triple number, because if that were the case, then we would know that triangle would equal circle, meaning that this card would be irrelevant. We would know for sure that, yeah, of course, if it's the same digit repeated 3 times, the first and last digits should be equal. So I don't think it could be a triple number. So what I'm going to write in my notes is that I'm going to deduce that it's a double number. So let's go ahead and type that up. And that's that the solution is a double number. Meaning, of course, you do have a pair in the solution. And of course, since we know we have a majority of odds, we know that it should be a pair of odds. We just don't know if that third digit, whichever one it may be, is going to be odd or even. We're not there yet. And I don't think we can really cross out anything at this point. Well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, checking the value of triangle versus 3. And of course, we did not test criteria card B, comparing triangle and circle. So, but I think everything else, well, yeah, I guess technically D is also somewhat outstanding in the fact that we don't know if it should equal to 6 or be greater than 6. Okay, so how do criteria card A and B sort of help us to come up with a good second round proposal? So again, our options are, well, we are looking for a pair of digits. So what if we say, hey, could it be 3, 3? What would that mean for circle? Well, there are plenty of options for circle to be either less than or greater than. Obviously not equal, since we already said that the 3s could be our pair in triangle and square. But I don't see, even if I knew, well, we don't know that third digit is even or odd, so there's always going to be 2 possibilities, either smaller than or greater than, to pick from. So no, I don't think it could be 3, 3 for a sum of 6. And likewise, it can't be 2, 4 either, because that would mean we have a majority of evens. So I don't see 6 working with 3s or evens. So then we're looking at, if it is a sum of 6, it's going to be 1 and 5. And then it could be that triangle would tell us which one it would be, 5 or 1, and then it would be equal. So something like either 1, 5, 1 or 5, 1, 5 would be the obvious possibilities for a sum that's equal to 6. Now, what about greater than 6? Well, again, we are dealing with pairs, so what would that mean? It just seems like there'd be too many possibilities. So yeah, let me go ahead and I'm going to do a sum of 6 with triangle being greater than 3. So I'm going to say something like 5, 1, 5 and see where that takes us. Okay, so again, the whole premise of the proposal was that the sum is 6. So let's actually verify that. So we'll retest criteria card D. Okay, yes, so the sum is equal to 6. So let's go ahead and modify our notes here that we've confirmed that it should be equal to 6. And remember, the only way you can get a sum of 6, as we mentioned, is either having 2 3s, or 2 and 4, or 1 and 5. So for that fact, just based on the previous conversation, I don't see it being 3 and 3 for the again, for the same reason of, yeah, we can find numbers that are smaller or larger than 3, but which one would you pick? I don't see a way where you could pinpoint, because we already have our majority of odds, 3 and 3. So circle could be even or odd, and I don't see any change. And again, it can't be 2 4 because those are evens. So let's go ahead and I'm going to cross out 2 3 and 4 for both triangle and square. Okay, and so let's go ahead and test criteria card A. And yes, triangle is to be greater than 3 because my 5 is greater than 3 and the Turing Machine approved it. So in general, we'll say that yes, triangle should be greater than 3, and that's an A. So triangle is greater than 3, meaning it can't be a 1. Triangle cannot be a 1. But because our sum is to be 6, that means square has to be 1. So you have that sum of 6. Okay. And so let's just verify, yes, sum of 6. So far we have a majority of odds. Okay, and I think we can deduce that B has to be that it's equal. Well, let's see. Can we say that? Can it be 5 1 1 or 5 1 5? Well, we need a definitive answer. So I don't think it's going to be less than, because, well, there's just a ton of stuff that is less than 5. Right? How would you pick between 1 1, 5 1 1, 5 1 2, 5 1 3, and 5 1 4? They're all less than. Obviously, it can't be greater than because triangle is a 5. So I think it's safe to deduce that it has to be equal. Remember, you do have to have a pair. Well, let's see. You do have to have a pair. Well, let's go ahead and do this. It can't be 2, and it can't be 3, and it can't be 4. That much is true. Either the 5 is paired up or the 1 is paired up. So you could say that they're equal, yeah. But then if you say it's less than, well, yeah, then you can pair up the 1. Yeah, I don't think there's a way we can deduce that, can we? Let's see. Yeah, I'm not sure if there's anything between criteria card A and B that would let us, if triangle's greater than 3, oh, then yeah, circle has to be less than. Well, not necessarily. I wouldn't think so. You do have a pair. If you have a pair, if you have a double number, well, it doesn't mean that triangle and circle have to be the equal ones. It could be, another combination of our digits. Yeah, I don't see any way to be able to narrow it down. I don't see some sort of deduction or combination of criteria cards that would help us do that. Yeah, we're down to just 1 or 5. It could be less than, it could be equal. Yeah, let's go ahead and just test criteria card B. Wow, fantastic, in the sense that had I not done that, I would have gone the wrong way. So 515 is not correct. In fact, it has to be less than. So, of course, since mine are equal, well, that's not going to work. We already said that triangle can't be smaller than circle. In fact, triangle has to be greater than. So we'll deduce that. And yeah, again, glad I made that test. So yeah, we're going to say we'll deduce that triangle should be greater than circle. And so that would mean that our solution is 511. Okay. So yeah, let's go verify 511. Five, one, one. Okay, yes, fantastic. And how do we do versus a Turing machine? Well, let's go see. So this was a 5 criteria card puzzle, and we did 6 tests. So we didn't equal it, but hopefully it's enough to maybe tie with a Turing machine. So in the first round we did C, D, E, and in the second round we did the remaining 2, A, B, but redid D. So let's go ahead and type that up. And again, C, D, E in the first round. So C was correct, D and E were both incorrect. In the second round we did A, which I believe was correct, D was incorrect, and D was correct. That was our equal 6. So, wow, okay, so fantastic. So we still beat the Turing machine by 1 question. Awesome. Well, I'm not sure, where that, I guess we had a couple of deductions here, but I think, it was good choices in the first round. Again, if you've watched some of my videos, I've at the beginning of gameplays, I would choose criteria card D for the second round. I've kind of learned my lesson and begin using it in the first round. Again, because there are 3 options, you don't want to sort of hamstring yourself and not be able to test it again in case it's wrong or something else. So I've kind of learned my lesson. Obviously, you also had criteria cards A and B, which also have 3 options, which, are not necessarily easy. You can easily deduce after 1 try. So sort of lessons learned, always adjusting the gameplay. Well, what about you? What criteria cards did you choose? And did you see anything interesting? Any kind of aha moments that you'd like to share? Add those thoughts into the comments. If you like the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so you don't miss out on any future videos. Well, until next time, have a great one.